So what we're going to do for Ca5 here, for polarity and intermolecular forces of attraction, is we're going to divide it into two. For today, we're going to focus on polarity first. So we're going to look at, or we're going to fill out molecular geometry and polarity only for today. So let's begin with molecular geometry. From your Ca4 work, the given molecules are actually the same with Ca5. And in your Ca4, if you look at the very last column, you see molecular geometry right there. So that is the molecular geometry that's being asked for this part right here, for molecular geometry here. So let's go back to CF4 again. CF4, the molecular geometry of CF4 is tetrahedral. So all you need to do is copy that word or type it in Microsoft Word, whatever choice you have chosen. So just put there tetrahedral. So just put the name of the shape. So tetrahedral is the name of the shape. I took it from the last column of Ca4. It's all in the last column, this part here. Okay? After that, let's look at polarity. So remember the notes that you copied on the conditions for nonpolar molecules. So let's begin to just look at those two conditions for nonpolar. The first condition is there should be no lone pairs in the central atom. How do we know that? So let's go back to the Lewis structure here. The Lewis structure, that's the only way. So you go back to the Lewis structure that you draw, look at the central atom. Does it have a lone pair? No, it doesn't. So 0 lone pair, 0 lone pair. So criteria 1 is done. It is correct. Next, let's go to criteria number 2. Criteria number 2, it says that all the terminal atoms have to be made up of the same element. Terminal atoms. So when we say terminal atoms, these are the atoms surrounding your central atom. So all the F's here that you see outside are your terminal atoms. And because they're all symbolized as F, all these atoms outside are made up of the same element because the symbol is the same. So therefore, criteria number 2 is also checked. So because the two criteria are met, therefore CF4 is considered a non-polar molecule. Again, what are those criteria that we met? 0 lone pair in the central atom. So let me just write it down again. So 0 lone pair in the central atom, and the second one is terminal atoms are the same element because all are fluorine. And that is the answer for your CF4. If we go to the second one, if we go to HCN this time, so HCN is number 2 here. So we have HCN, our drawing here. Look at our drawing. This is the clean drawing of HCN here. The first thing we need to do is look at its molecular geometry. Molecular geometry here is linear. So all we need to do is write down linear here for the column of molecular geometry. Then after that, let's check if it's polar or non-polar. So let's go back to our two conditions. Does it have a lone pair in the central atom? Does it have 0 or does it have any? So let's look at our structure. This is our central atom, the one in the middle. Does it have any remaining dots? No, it doesn't. Doesn't have a lone pair, so 0 lone pair. So criteria 1 is okay. Next, criteria 2, the terminal atoms must be made of the same element. Let's check the terminal atoms. Terminal atoms are H and N. Are H and N the same element? Obviously not, because H is H, that's hydrogen, and N is nitrogen. Those terminal atoms are different elements. So criteria number 2 is not met. Automatically, if one criteria is not met, therefore it is considered a polar molecule, because the terminal atoms are made up of these different elements H and N. And that's what makes HCN polar. Okay? And my last example before you proceed to the other items is the third one. We have the NH4 plus ion. Okay? So what is the molecular geometry? It says here tetrahedral again. So all we need to do is write down, I'm sorry, NH4 plus is not here, right? So it's SiH4. I'm sorry. So it's SiH4. We did not include NH4 plus anymore. So SiH4. Let's go to the molecular geometry. Very last column here. It's tetrahedral. So we will put tetrahedral for SiH4. Okay? Then after that, let's look at if it's polar or non-polar. Let's look at the drawing. First criteria. Does it have a lone pair in the central atom? No, it's 0. So criteria 1 is okay. Second criteria. Are the terminal atoms made of the same element? H, 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 H. They're all hydrogen. So all the terminal atoms are made of the same element. So criteria 2 is okay as well. So both criteria are there and they're all met. So therefore, the molecule is non-polar because the two criteria are there.